Hey guys, welcome. I'm Brandon. And for this video, we're going to replicate what you're seeing in this example here for Hades, which is to have the camera follow the player when you're using a gamepad, but have the camera follow the mouse position when you're using a keyboard and mouse control scheme. I did quite a lot of experimenting with this to find a system that will work no matter what your setup is. Side scroller, top down, perspective camera, orthographic camera, doesn't matter, this will work for your project. Ready? Let's go. So the very first step we need to make is to ensure we can detect our mouse input. So let's do it properly by adding it to our input action asset. I'm just going to create a new action and call it mouse position and set it to value of type vector2. And let's make sure it's picking up the mouse position. And obviously, if you clicked on this video, then we're working with multiple control schemes here. So I've got two control schemes, keyboard and mouse, which requires both a mouse and a keyboard. And a gamepad control scheme with a required gamepad. And let's make sure that the mouse position is only being used in the keyboard and mouse control scheme. Okay, so there's a lot of different ways of picking up input in the input system, but I'll show you my favorite way, which is easy to read and very accessible. So we're going to double click this so that we can just copy it. And I'll go into my user input script here. And the only thing that's already here that I want to point out is that we have this static player input variable, which we set in the awake function. We'll be needing that soon, so if you don't have that, go ahead and add it. And also make sure to add a player input to your input manager game object or whatever object is holding your input script. So let's set up two variables. One is a static vector2 for the mouse position, and the other is a private input action. We'll set up the input action in the awake function, and then you can paste that string that we copied here. And in the update function, we can set the mouse position to be the action.read value of type vector2. Perfect. So you can see if we log the input, it will return the screen position 00 on the bottom left and the screen width and height at the top right. And you can see that if you open your stats. Next, let's get the camera to actually follow the mouse position. And I'm using Cinemachine here with a simple 2D virtual camera. So the absolute easiest way to do this is to just create an empty game object and plug that into the follow slot in the virtual camera and have that empty game object smoothly follow the mouse with some sensitivity controls. So let's create a new empty called camera follow and create a script with the same name and attach it. And let's plug this into the follow slot right now and then open it up. All right, so let's set up a float with a range of 2 and 100. We're also going to want a reference to the camera and the player's transform. And let's create a vector3 for our target position as well. And first, since we plugged this game object into our camera, we can no longer see our player in the game view. So to correct that automatically, let's move the transform in the onValidate method so that as soon as this script is recompiled, it'll automatically always find the player and move it there. There we go. So in the update function, let's make sure the player's transform isn't null. And we're going to say the target position is equal to the mouse position, but we don't want it in screen space. We want to convert that into a world point, which is a function we can call from our camera. Now from this, we can find our follow object position, which is the target position plus the follow sensitivity minus 1 multiplied by the player's position divided by the follow sensitivity. Okay. And then set our camera follows position to be equal to that position. So let's give this a test. And by the way, the lower you set this float, the more sensitive it's going to be. So I'm going to do something like 3. Now, if you are using an orthographic camera, this should already be working, which is awesome. If you are using a perspective camera, this will do absolutely nothing. And if we debug the target position, it's just going to return the exact same position as the virtual camera. There you go. You can see they're exactly the same. That's because perspective cameras are for 3D, so they're a little bit more complicated. And I know I'm working in a 2D scene here, but even for 2D games, using a perspective camera can be great because it's an easy way to implement parallax layers. And that's what I'm doing here. So that's why I'm using a perspective camera in my 2D game. So let's set up a system that will work for both an orthographic camera and a perspective camera. So instead of this line, we're instead going to shoot a ray out from the camera using screen point to ray. Now, in most cases, what you'll do here is say if physics.raycast and then output the result into a local raycast hit variable, and then check if we hit something like the floor in a top-down game or whatever. I don't want to do that here just because I'm using a side scroller and I want a solution that will work everywhere, even if it doesn't hit anything. So instead, I'm going to set the target position to be equal to the ray's origin plus its direction multiplied by the distance that the camera is on the Z position. And I'm going to add mathf.absolute so that it returns a positive number. And then I'm going to set the Z position to 0. So really quickly, let me show you what's going on here. And this is just to demonstrate, you don't need to follow along here. I'm going to comment this out and just set the position equal to our target position for now. And I'll add a sprite so that you can visualize it and change the target back to the player just for a sec. So you can see the sprite is following the mouse, but as soon as we get into the corners, it slows down and it's not following as well anymore. And this is because the camera is in the center. So this is further away because of the depth, because this is a camera for 3D and we're zeroing out the Z. So it's a little less sensitive in the corners, but I have played around with this and it feels and works great regardless. But if you are not working with a side scroller and you're always going to be hitting something like the ground or a wall, then you might want to complete the raycast option I showed you just a second ago, because it will hit the ground or a wall so long as it has a collider, and that will be a little bit more precise around the corners. But the cool thing is we can see that this works for both orthographic and perspective, which is awesome. So I'm just going to put it back to the way it was. Now, one optional thing that you might want to add is you'll notice that it continues to track the mouse position even off screen, which is kind of annoying, especially in the editor. So let's go ahead and fix that. Let's set up a rect and initialize it as a new rect at our screen's width and height. And in our update, let's add a check to make sure that our screen rect contains a mouse position on it. Let's test. There, now you can see that the script stops trying to follow the mouse once the mouse is outside of the game view. Okay, so this is great, but now we need to figure out how to swap between this when we're using a keyboard and mouse and centering on the player when we use a gamepad. So we're going to need to open up our user input script again. And let's set up some static strings for our control scheme names and make sure that they match what you typed out in the input action asset exactly. So we know we need a function that's going to set our current control scheme to be equal to our player input's current control scheme. We just need to know where to call this from. And that's where player input comes in so handy. So we're going to make sure that the auto switch is turned on and set the behavior to invoke Unity events. And if we expand this, we have a controls changed event already set up for us, which is awesome. So let's plug in the input manager and call the switch controls method. And to test this out, let's go ahead and put a debug.log in there. The player input also shows some debug info when you're in play mode, so we can really just compare that to our debug logs. So it defaults to the keyboard and mouse, and if I press anything on my gamepad, yep, it switches, and if I touch the keyboard, it switches back again. Awesome. Now, one additional thing really quick, I find it really annoying that if you're moving your player with the gamepad, but then you accidentally like bump the mouse, or if you're just moving it, the keyboard controls take over and the player stops moving from the gamepad input instantly. And it feels really jarring and unnatural. And if you want to fix that, you can actually just add the mouse to the gamepad control scheme as optional. Now you can move the player using the gamepad even if you're moving the mouse around. So now that we know about this event here, we can just set up a method to change the virtual camera's follow to either the camera follow or the player, depending on which control scheme is being used. So we're going to set up a script called camera target switcher, and I'm going to add that to my virtual camera and open it up. So this is pretty straightforward. So let's set up a couple of variables and grab what we need in the awake function. And this method will be called from our input manager's onControlsChanged event. And we'll say if the current control scheme is the keyboard and mouse, then we'll set the virtual camera's follow to be equal to the camera follow. And if it's the gamepad control scheme, then we'll set it to the player. So let's go ahead and add that to our event here and give it a test. And this is really interesting, actually. We're getting an error, and that's because the controls changed event is being called in awake before our awake function in this script. So we actually have two choices to fix this. We can either just make the virtual camera serialized, which will give it the reference immediately, even before the awake function is called. See, no error. Or just in case you didn't know, I just wanted to show you this real quick. You can also go to Edit, Project Settings, Script Execution Order, and we can actually add our camera target switcher in there. And so long as we place it above our player input script, we'll be good. Because now the camera target switcher's awake is going to be called before the player input's awake. Hit apply to save the changes. All right, let's test. Awesome, no errors. And also you can see that the camera is now following our mouse. And if I pick up the gamepad, very nice, it switches over to our player. The only thing I don't like about this is that the transition between the two can be a little bit jarring, and I'd really just like to smooth that out a little bit. And you could unassign the follow method here and then manually move the virtual camera with the force camera position method and lerp it. Except the end result from that doesn't really look as good as it could because all these framing options get ignored if you do it that way. So instead, what we're going to do is create another empty game object and use it as a transition between the changes. So let's get a reference to that. And we're going to want two bools, as well as some floats and a vector 3 to control our lerp function. Also, let's go ahead and make sure that the transition follows position is right at the player's position when we start the game. Otherwise, when you start the game, there might be just a little bit of camera movement, which can be a little bit jarring right at the start. So down here for both, we're going to change the virtual camera's follow to the transition follow. And we're going to make our start position for the lerp equal to our virtual camera's current position and set the applicable bool to true in each spot. And actually, just in case we're transitioning during an old transition that's already happening, let's set the old one to false and reset the timer in each. Now it doesn't matter how often you do it. Now let's add an update function. And we'll say if we're transitioning to player, then we'll move the object and handle the timer. And in this function, we're going to increment the timer, set a local vector 2 to be equal to the lerped position from our starting position and our end position. And to make it a percent, let's say timer divided by duration, and then set our transition follows position equal to that lerp position. So let's plug that up here with our end position being the player's position and say if our timer has reached the duration, then we set our bool back to false, and finally set the virtual camera's follow to be equal to the player. Since now the positions will be exactly the same, so we just want to move over from the transition to the player and follow the player. For the camera follow, it's going to be very similar. We're going to move the object with the end position being the camera follows position. And again, if the timer has reached the duration, then set our bool to false and set the virtual camera's follow equal to the camera follows transform, because again, the transition is now over. We're at the exact position of the camera follow, and now we want the camera to actually follow the camera follow game object. I hope that made sense. All right, and to test, let's make sure we plug in the transition object. Now you can see it's following the mouse, and if I switch to gamepad, it transitions very nicely, and same if I switch back the other way as well. And again, this works for both orthographic and perspective cameras. That's all I got for you guys. I hope you enjoyed, and I hope you really found this useful. Like the video if you liked. I know it's a small thing, but it really helps with the reach of these videos. And also my patrons get access to the source files of every tutorial ever made on this channel. So if that interests you, then head on over to Patreon. Thanks so much for watching. Bye. I want to give a very special thank you to all of our Hall of Fame patrons: Jakob Yondok, Christopher Nichols, Zandra Kessler, Fontaine Waite, Brainwaves to Binary, Couch, KB at Bird Tech Games, and Ian Oral, as well as our early access patrons: Ken Waite, Mason Crow, Mr. D, Liquid Egg, Alexander Prestis, Jude Greaves, Felipe Gomos dos Santos, Ober, Francesco Latamata, Bill Guo, Alon on Mars, Alex Friedman, Danny Rathliff, Neil, Ben Kerberger, Lucky Tales, Aiden Serve, Adarsh Kumar, Merler, Anastasia Shamalina, and Petr Juricek. If you choose to support us on Patreon, you can get early access to all of our YouTube videos, monthly alpha builds, and more.